Hello, my name is John. This is my course project for Duke's Managing Machine Learning Projects. We will be evaluating a machine learning-based model to help individual derivative, mainly options contract investors, predict the outcome of their future trades. When trading in derivatives, mainly options, futures, etc., as an individual investor, it can be difficult to identify investment opportunities. There are millions of different trades that could be made, and identifying the ones that match your specific criteria is a problem that is not solved well today. In addition, opportunities exist in providing user-specific trading data that identifies opportunities based on past trading behaviors and outcomes. This is an attractive problem for a machine learning product. From a market or competitive standpoint, it is a problem that is not solved well today through fragmented trading screeners that deliver a lot of suboptimal experiences. In addition, this involves the user's ability to make or lose money and is a product that could possibly be monetized if you find product market fit. So given how expensive we inherently know this type of solution could be to build, we will want to have a solid business understanding as a foundation for the rest of our crisp DM process. This starts with a good understanding and crisp articulation of the problem. We will attempt to clearly define our target user as individual investors that typically use trading platforms such as Robinhood, E-Trade, or Interactive Brokers, and place a material, we'll say 10 or more, derivative trades a month. If we further unpack the problem, we find that the user needs to sift through a tremendous amount of derivative data, options premium, expirations, order flow, as well as information about the risk of the trade, company health, the liquidity that exists, really across millions of potential trades. In addition, their past behavior that they've used previously in trading as it relates to risk appetite, trading behavior, wins and losses can be vital information to help inform future trades. We believe this really matters because individual investors are increasingly using derivatives like options for everything like generating income and hedging risk to making outsized market gains and losses on trades. In addition, there are a significantly number of low-quality, high-risk trades involving unhealthy companies that could be presented and are in today's option screeners. These may technically match the investors' trading screeners, but may not be the types of companies or trades that they have historically made or will want to make in the future. And currently, investors are relying on poorly built experiences in their trading platforms like E-Trade and Interactive Brokers. Investors are using fragmented solutions that only solve part of the problem. A service for option screening based on predefined criteria, different service for options order flow, another one for placing trades. And it doesn't really readily appear that anyone has solved combining this macro level market data with investor specific behavior data in an effective product. So as we transition to talking about what success looks like, I think our expected outcome, our expected impact would be really investors are more confident in their trades because they are more informed with the right data, and subsequently they pay for the product. Some of the user focus outcomes we would target would be things like percentage increase in profitable derivative trades, percentage decrease in unprofitable derivative trades. We'd also do user research to assess, are they feeling more confident, for example. As we look at our model, the output metric would be the mean squared error of the aggregate predictions for these unprofitable or these profitable and unprofitable trades that are the user-focused outcomes. Some of the constraints we would have would be that the data must be updated real time and the model trained at least daily based on changing market conditions and recent user behavior. And we would need extremely low latency in order to allow the user to make trades in a timely fashion. Some of the relevant factors used as inputs in our model would include things like the derivative data, such as the options premium, strike prices, expirations, data that they call the Greeks, user-provided preferences around timeframes, risk profiles, preferred trading strategy, as well as that user behavior data around are they selling versus buying options, what are their hold periods, what have the success rates been of their past decisions. So now that we have a set of hypotheses around the problem, a solution to this problem would provide an online machine learning model with a simple user experience that aggregates macro level derivative market data, investor trading preferences, and investor behavior to successfully recommend appropriate trades and predict their probable outcome. We would look to run a number of validation experiments. We would start by validating that the market investor preference data can be sourced, that it can be transformed, and that the predictions can be made within the latency requirements. As we look at the model, we would introduce investor behavior data with the fewest number of features possible and validate its impact on increasing profitable trades while decreasing unprofitable ones. And then we would look to add in very strategically and in a prioritized fashion, additional prioritized features from that investor behavior data into the model, constantly looking to measure the impact of each feature on our desired outputs and outcomes. When evaluating our system design, we would look to make decisions in 3 critical areas and with the following rationale. We would most likely use Cloud ML versus Edge. Although the low latency of Edge ML is attractive due to the high throughput of a vast amount of quickly changing data, we would use Cloud ML that requires network connectivity. We would use online learning versus offline. Again, due to the high frequency real-time changes across a vast amount of data and the need to be trained on the investor's most recent trading behavior, online learning is the best path forward. And then lastly, we would use online predictions versus batch due to the on-demand and immediate need for the predictions. There are potential risks we foresee as we think about this product in production. We may see training serving skew if the training data is too artificially clean and does not reflect production. We could experience too much latency and the prediction is generated too late for the investor to make a successful trade. Market, investor preference, and investor behavior data needs to be real-time or near real-time, and that's likely to incur significant cost and complexity to prevent any sort of data drift there. And then lastly, investor behavior patterns may not be appropriate for changing market conditions or changing investor sentiment, and we could experience concept drift. Thank you.